In this chapter, we will have a look how works volumetric lighting. Volumetric lighting doesn't work without Redshift environment. That's the place when you will set up volume scattering. And as a second rule, you have to set up correctly your light, and under Volume tab, you have to enable Contribution Scale. And now, as you can see in our render view, we are getting volumetric results. If I will turn off our model, now you can see our point light without the model interaction, so volumetric breakup which you see depends on the shapes which are colliding with our light. Go to Redshift menu, Lights, Spotlight. Change position of the spotlight to be towards on our ground. And now I will show you how to activate volumetric light. Select your spotlight, go to the Volume tab. Contribution scale is 0, so we need to have contribution scale higher than 0. And as second step, go to Redshift menu, Objects, and the Redshift environment. And immediately you can see visible our volumetric light. Intensity of our volumetric light depends on more than one parameter. First, we will have a look on the scattering. As you can see, if I will decrease scattering, our volumetric light getting much more realistic results. Also, all Redshift lights under Volume tab have contribution scale. So as you can see, we can choose level which is best working for us. And also how looks our volumetric light depends on the intensity and scale of your lights. So as you can see, as I'm manually changing size of the light, I'm also increasing our volumetric representation. But we always can use exposure and lower brightness exactly as we need. And as you know already from our light chapters, your light can use also texture. And now you can see in render view how looks volumetric texture projection. But as I said, important is to use Redshift environment if you would like to see this kind of the results. Let's do have a look on different scene with point light, and as I mentioned, intensity multiplier affecting brightness of your volumetric light. Also, you can control under volume section contribution scale of your light. And now it's time to have a look on details in Redshift environment. As first parameter, we have color tint. And as you can see in our render view, we can change color of our environment. Also, it's important to know that if you are changing color of your light, color of your volumetric light will be affected as well. Back to our Redshift environment. Next parameter, we have scattering. As I showed you before, scattering affecting how strong should be volumetric light effect. Next, we have attenuation. Attenuation means density of the environment. So more attenuation creating more density in our environment, or opposite, less density bringing more transparent results. Another parameter is phase. Phase means backward or forward scattering. Or also you can know it as away from camera or towards the camera scattering. And in our render view, you can see how it looks if I'm going to negative or positive values. Also, it's good to know if you need to use more attenuation, maybe you will need more scattering as well, because there is always connection between these two parameters. And now I will show you one more time how affecting phase your final result. Our Redshift environment has also sliders for ray contribution. So as you can see, you have control of camera, reflection, global illumination, or environment fog. But for more details about fog, we are going to the next chapter. In this chapter, I will show you how to create environment fog. Go to Redshift menu, Objects, Redshift Environment. As I showed you before, we are using Redshift Environment also for scattering volumetric light. But this time we do not need to scatter any light, so I will use for scattering value 0. What is the much more important is attenuation. Until is attenuation 0, your fog or density of your environment is invisible. So if you would like to set up correctly your fog, you have to use attenuation parameter higher than 0. And now you can see in our render view how looks our environment fog. Default fog emission color is black. That's the reason why currently our fog looks very dark. So as first step, we will change emission color to get different kind of the look. And as you can see, now you have full control of color of your environment. Brighter colors you will use, brighter results you will get. And now we can go back on attenuation to find balance which will better work for our purpose. So as you can see, attenuation and emission are two main parameters how to set up color of your environment. And as you can see on our example, it doesn't need to be always just white fog. It can be also environment which looks a little bit more darker, or even some kind of the old interior where is a lot of dust. But for exterior daylight, definitely set up much brighter colors. Next parameter we have height, which is fall off of your fog. Until it's height on 0, we have covered entire environment. If we don't want to cover entire environment, and let's to say we would like to have fog just around the ground, but not on the other places, we will use height to specify how will fall off our fog. It will create fog horizon, so we can use horizon blur to make it even softer. And horizon position we are controlling manually in viewport by using transform. Our second option is to use ground point and ground normal values. I definitely prefer to use transform because I have visual control, so as I am moving with our horizon, I see immediately in my render view how looks my results. Also I can use rotation, and as you can see now, my front part closer to camera is much more clean than before, so it can be very helpful for my final composition. Find correct position of your environment which is the best working for your scene, and after that come back to height or horizon blur, and as you can see, these parameters will help you to set up exactly height, fall off or softness to correctly complete your scene. As second example, we have brighter ground fog. So as you can see, I'm using brighter colors. Now a little bit attenuation. And instead to cover entire environment, we will use height to get it just as you can see on the horizon, closer to ground. We can transform with our horizon. Now you can see us affecting the fog our scene. And also now are much more obvious height changes. Slider range for height is finishing on the 100, but if you need higher numbers, you can manually override it in the height field. In this chapter, I will show you how to create environment noise. As you can see on my example scene, you have to have RS noise material connected into the volume and applied on Redshift environment. You have many noise parameters which will help you to create fog breakup exactly as you need. But in this chapter, we are not going to explain noise parameters. About noise parameters, we have two separated chapters, so check them out. And as you can see, as I am changing noise parameters, we are immediately getting different kind of the results. So after our course, you will be able to create really interesting environments. Go back on our environment volume scattering, and if you will increase or decrease your scatter, as you can see, you are changing mood of your scene. But all those parameters are explained already, so we do not need to spend time with this anymore. But what is important is your practice, and you have to try to create your own scenes, and you will even better understand how those parameters works. For this scene, I created bigger area light. Go to Redshift, Objects, Redshift Environment. Now select your area light, go to Volume and allow contribution. 0.1 should be more than enough. And as you can see, as I'm going lower or higher, we are changing visibility of our volumetric light. So I will little bit lower intensity of our area light. And now we are getting from the top interesting volumetric results. So as next step, we can tweak Redshift environment parameters, and we will use little bit attenuation to get little bit more dense volumetric look. And now go to Redshift menu, Materials, Utilities, Noise Volume. Apply this material on Redshift environment. And as you can see in render view, now we are starting using RS noise to break up our volumetric results. Select your RS noise material, edit shader graph, and now we have access to tweak our noise exactly as we need and create our noise environment. I created few RS noise examples to demonstrate what everything is possible to create if you are using RS noise on Redshift environment. So now you get an idea how to create noise volume material to get very interesting volumetric light results. And of course, for final touches, select Redshift environment and you can do other tweaks exactly as you need. And now visit again about the same workflow what I showed to you already in other chapters, so you can just use your knowledge and be creative with your own scenes. In this chapter, we will have a look how works 3-point light setup. It's very common setup for photography portrait, models or products as well. Currently in our render view, you can see how looks our scene if we are using only Redshift default lights. In our 3D viewport, we will use our working camera, but as you can see in our render view, I locked pose camera, so now I can see much better changes which I am doing in our 3D viewport. 3-point light setup using key light, fill light, and backlight. Let's to activate them all, and now you can see in our render view how different looks our scene. As you can see in our 3D viewport, it's very simple light setup using 3 area lights with different scale and intensity and around 45 degrees angle, which will help you to create more realistic results. Let's do switch in our render view, working camera as well, so we will match viewport with our render view. And now immediately you can see that we have different intensity from fill light than we had before from key light. If I will turn off fill light, you can see that our lighting is immediately incorrect. It's not necessary to have from all sides the same intensity of the light, but also is wrong when on your model appear black patches. Let's turn on back our fill light and immediately you can see how much better looks our lighting. For fill light, you can use any intensity which is working for your scene. Just don't forget that fill light is secondary light, so very often you are using fill light with lower intensity than main key light. And if you need to use fill light with very low values, always be sure that you are not getting any black patches, And that's reason why we will switch in our render view from regular to clay mode. And as I said in chapters before, clay mode is exactly the best mode if you are preparing lighting of your scene. So now I have better control how much I need to increase intensity of my fill light. Let's to rotate with our scene. And now we can see how works our current lighting setup. As next step, I will show you why we need to have backlight as well, because if I turn off backlight, as you can see again we are getting black patches. So always check your model from all sides to be sure that your lighting setup working correctly. And change intensity, size or position of your lights exactly as you need. Let's switch in our render view from working camera to post camera. And now I will show you how affecting size and position of our key light our final result. Bigger area lights produce more intensity. Smaller area light produce less intensity, so with smaller light you have to go closer to object to get the same intensity which producing bigger lights. But as you can see, closer your light is to object, more contrast and more sharper shadows you are getting. And that's the main reason why it's very important to find correct size and position of your key light for more realistic lighting of your scene. And naturally light coming from top, that's the reason why we are a little bit rotating with our lights to have around 45 degrees from top. And now I will show you example what's happening if we are rotating not towards to our object, or we are in the incorrect position, or too low with our light. Immediately you can see in our render view that something's not working, but now you will know why. And here is one more example when we are going even lower with our light and we are rotating not from the top but from the bottom. So as you can see, that's exactly example when is your lighting not working anymore. In our render view, we can see how looks our scene with default lighting without post effects or volumetric lights. If I will activate dome light, you can see how drastically change our lighting, how different looks reflections now because of HDR map contribution, and also our lighting looks much more colorful. Let's activate backplate. And as next step, we will activate our volumetric point light, which is behind the gun to separate gun from the background. For this kind of the separation, you can choose intensity or color exactly as working for your scene. And how to create volumetric point light, we had already in chapter volumetric lights. To have even more interesting look, I created another volumetric light from the top of the gun, because all these small details creating much more interesting results and also making feelings of better, more realistic integration. And as next step, for all self-illumination parts, I am using Redshift Post effects, which are very helpful to create another level of photographic effects, and I will show you all details about post effects in separated chapter later. You can use Spotlight to create some kind of targeting looking volumetric light, but I will show you in this example how you can get this result with point light if you will use light to collide with the geometry. Select point light and move with your point light inside the geometry, and as you can see, shape of geometry break up our point light, so now position of the light will affect final look of your volumetric light, and you will get realistic looking results. In this example, I will show you how to use light target. Go to Redshift menu, Lights, RL Light. Select Area Light, go to General tab, click on this icon, and here we can create target tag and null. And as you can see, our area light now using target tag, and also was created null with name iris area light target. And now, as you can see, as we are moving with our target, our light following target position. Now I need copy of our camera, and I will use it as working camera. Activate camera, delete protection tag, and in our render view, I need to lock camera. Be sure that it's locked correct camera. And now we can use working camera and start to prepare our lighting. First, we will hide our camera interpretation in our 3D viewport. And let's do hide ground plane as well. So now our scene looks much more clean and it will be easier to adjust our light. Select your area light, and now as we are moving with our light, we are always following our target. So let's first to find correct position for our target. As you can see in our render view, we need to select our light and increase intensity. And now we are ready to find correct position. And as you can see, our light following our target, and we do not need to rotate with our light anymore. Also, you can change size of your light. And now you get an idea why it's so helpful to use target for your light. In this example, we have low light intensity night scene with one area light as key light, and we're using two volumetric lights as I showed you in the example before. But as you can see, our area light is not covering entire ground correctly and we are getting black patches. And for this kind of the scene, we can use default dome light to rid off of black patches and increase little bit intensity of our night scene. As you can see, I'm not using any HDR map. Everything has default values. But what we would like to drive is our tint color. Darker color values, as you can see in our render view, produce less light intensity of our dome light. And in this case, brightness and saturation of color will work as your fill light. So you can easily rid off of your black patches, and also you can bring more color variation into your night lighting. In this example, we will have a look how color variation can improve our lighting if we will use for key light warmer color, and for our fill light colder color, which is exactly opposite. As you can see in our render view, we are getting color variation and our scene looks much more interesting. And here is one more example. How can color temperature make saturated and nice looking lights in our scene? As you can see on our example, even we have enough lights in our scene, still we are getting too dark parts. And the reason is because we are missing light bounces. For light bouncing is responsible global illumination or GI. Go to render settings, click on redshift. Now you can see GI tab. And under GI section we have primary GI engine and secondary GI engine. And both as default are turned off. So if we would like to use our primary GI engine, we have to choose one of the method how we will get our global illumination. I'm always using as primary GI engine brute force. And as you can see in our render view now, global illumination helping us to get much more realistic results, and light bounces rid off of our very dark parts. To see it even better, let's switch to clay mode. And here is how it looks without GI. And as you can see, we have many dark patches. And now with GI, So now you can see how big difference it is if we are using GI, and why is GI important if you would like to have much more realistic results. And to get even more details, we can use also secondary GI engine. As you can see, we can choose from free options here as well, but again, I'm using mostly brute force. And in our render view, you can see how improving our GI if we are using secondary GI engine. So we are getting even more bounces, which are improving our final result. And for deeper understanding, here you can see how works one bounce from primary GI engine and how works more bounces from secondary GI engine. GI is very often producing grainy results. If you are using brute force, you have to increase number of rays to get more clean results. My start point is 256 rays, but very often, depends on your scene, you need to use much more rays to get clean results. Also, you can choose number of GI bounces, so always start with a lower number, and you can increase if you really need it. But more bounces needs more calculation, so it's of course affecting your render time and not always is changing your result. And don't forget that progressive rendering in your render view is not showing you final results of your GI. So if you would like to see your final result, you always have to switch to bucket rendering or use final render. And never tweak your samples or rays if you are using progressive rendering. And here is second example to see how global illumination improving scene where is many objects or walls. Go to render settings, redshift, GI, and as engine we will use brute force. And immediately you can see in our render view how bouncing light produced by GI can improve lighting of our scene. Objects closer to wall or ground, getting more light bounces, so they are more affected by GI than other objects. Let's switch to clay mode to see it even more obvious. Here is result without GI. And now when we are using brute force as primary GI engine. And if you would like to know even more about GI, check out Global Illumination bonus chapter, where we will have look on other types of the engines as well, and also I will show you why most of them I'm never using.